Hi everyone, welcome back to Geeks for Geeks. In this video, we'll be discussing the problem children, sum, parent. Basically, in this problem, you will be given a binary tree and you have to check if all the nodes are satisfying a condition. And the condition is that all the nodes in the binary tree must be equal to the sum of the children nodes. Okay, so suppose if we take the first test case, that is we have the tree 10 and on the left of 10 we have 10 as a child and the right child is basically null. So if you will see, since 10 is a leaf node, so you will ignore it because it doesn't have any children, so that's why you will ignore, right? But in the case of the root node, actual root node, that is 10, you can see that for it the left is what? The left is basically 10 and the right child does not exist. So you will say that if the left child exists and the right does not exist, so what is the sum of the children? The sum of the children is basically 10. Is it equal to the parent's value? Yes, it is equal to the value of 10, that is the root node. So then you can say that yes, for this particular tree, all the nodes are satisfying the condition that for a particular node, its value is equal to the sum of its children. Now, this property needs to be satisfied for all the nodes, right? So what we will do here is, if you see the next test case, so obviously what every node will do is, every node will return a data, right? Every node for every node, you will be observing whether it is following that criteria or not. Okay, if it is not, then you will return 0. If it is following that criteria, then you will return 1. That is true, that it is following the criteria. And at the end of the day, whatever is returned from the root node, either 0 or 1. So if 1 is returned, then this will mean that all the nodes are satisfying the condition. Otherwise, if 0 is returned, so this means that there are some nodes which are not satisfying the condition that the sum of the children should be equal to the parent's value. So let us quickly see this example here. Right, so if you see here, let's say if we have 1, right, if we have 1, then we have 4, then what we have is we have got 3, right, then after that we have got 5, and then we have got this right child of 4 as null here, right? Since 5 is a leaf node, I will return 1, or you can say true, indicating that since it is a leaf node, so it doesn't have any children, so I don't need to check that relationship, and I get this node as null, so from that also I'll return 1. Now for this particular node that I am at, that is 4, I will check what my left and right are returning. So left and right are returning 1, means that they are following the property. Now with respect to this node 4, is the sum of the children nodes equal to the value of 4? No, because 4 plus null, that is null is 0. So 5, like basically 5 is the child and then null is 0. 5 plus 0 is 5. So the sum comes out to be 5 for the children and the node value is 4. So the sum and this thing is not the same. So here you will return what? Here you will return 0, right? Because if the children are following the property, so the children are returning 1, that they are following the property. But if the sum of the children is not equal to the parent's value, then I need to return 0 for this particular parent, that is 4. Now when I go to 3, so for 3 what will happen? We will be returning 1, because since it is a leaf node, so we can say that it doesn't have any children, so that's why we can return 1, indicating that it is following the property. Now for this, with respect to this node 1, you can see that the left is returning 0, that is false, and right is returning 1. So since left is returning 0, so this means that there is at least one node which is not following the property, and from any of the calls, that is either from the left side or from the right side, any subtree returns that it is not following the property, then I need to return what? I need to return 0 only. Why? Because if any node is not following the property, in that case we can say that the whole tree does not follow the property, that for every node its value is equal to the sum of its children. Okay, so basically for this we can first of all call on the left, then we can call on the right, and then we will process the data for the root. Okay, so I hope that this part is clear, and since we'll be traversing inside the tree, so that would take nothing but order of n time. Let's take one more example. Suppose that what we had was, if we had 5 here, right, and then what we had was, suppose we had got 3 here, suppose we had got 2 here, and with respect to 3, let's say we had got 1 here and we had got 2 here, right? So if we had, let's say, this particular data, then from here what we would have returned is, we would have returned 1, right? Because with respect to 1, since it is a leaf node, so I'll say that it is following the condition, so I would have returned 1, or you can say true. With respect to 2 also, since it is a leaf node, so I would return 1. 1. Now left and right both are 1, so this means that they are following the property. Now I will check the sum. So the sum is what? The sum of the children is 3, and this particular parent is what? 3. So the sum of the children and the parent is same, so I will be returning 1 from this particular subtree. Now the calls will be made on the right as well, and since 2 is a leaf node, so it will return 1. Now from left and right I am getting 1. Okay, so this means that they are following the property. Now I need to check whether the sum of the children, that is 5's left child and the right child, their sum is what? 3 plus 2 is 5. Is it equal to the node value? Yes, then I will be returning 1 from here. So this indicates that this particular tree, in this particular tree, all the nodes are satisfying the property that the sum of the children is equal to the node value. Okay, so let's try and code this up and see how we can implement this particular problem. Okay, so what we will do here is we will first of all write a function here. Okay, since we have been given this particular function to check, so what we will do is we can make this as a recursive function only, and suppose if we are at a particular root that is null, so in that case what we will be returning is we'll return like you can say 1, indicating that yes, it is possible. Okay, because if I'm at a null node, so we don't have to check for anything. And also one more thing, if suppose that the root dot left, root arrow left, basically dot left will be in Java, roots left is null, suppose. Okay, and at the same time what happens is roots right child is also equal to null. In that case what we will do is we will simply return 1. Why? Because if it is a leaf node, then it does not have any children, so that is why I can directly return what? I can directly return 1 in this particular case. Okay, now once these cases are dealt with, then we need to call on the left and the right. So we need to get the information from the left subtree and from the right subtree, that whether they are following the condition or not. If either from the left subtree the condition is not being followed, or from the right subtree the condition is not being followed, then we need to return 0. Otherwise we need to check for the roots condition. Okay, so what we can say is that int L is equal to what? Recursion will call this function that is some property. Okay, property function, and then I'll pass the roots left here. Okay, and then after that I will call on the right also. So int R is equal to what? Is some property, and then I will call for the roots right child. Okay, then after I have got the information from the right subtree and the left subtree, then I will check if either the left is equal to 0 or the right is equal to 0. So this means that either the left subtree is not following the criteria or the right subtree is not following the criteria, then we need to return 0, because if any of the nodes is not following the criteria, then we can say that the whole tree is not following that criteria. Okay, otherwise if the left and right are following the criteria, then I need to check what? Then I need to check the sum. So I will initially mark the sum as 0. Okay, and the sum will be storing what? The sum of the left leaf, root dot left and root dot right. So basically I'll check if the root dot left, okay, if it is not equal to null. If it is not null, then what I will do here is, if it is not null, then I will add its data in my sum. So sum plus is equal to root dot left dot data. Okay, and then after that what we will do is, if the root dot right, that is root's right child, is not equal to null, if it exists, so basically when the children are existing, it is not necessary that the both will exist, so we have to check individually. If the left exists, then add it in the sum. If the right exists, then add it in the sum. Okay, then after this what you will do is, if the root's right child is not null, then in the sum what you will add is, you will say sum plus is equal to roots right child's data. Okay, right child's data. And then after that what you will check is, you will check that if the root data is equal to the sum of the left and the right. Okay, either both might exist or one of them might exist, depends on the scenarios. So basically sum will contain the sum of the leaf like children nodes. Okay, and it might happen that only one child might exist. Okay, so if the root data is equal to the sum, then we need to return 1, indicating that yes, this node is also following the criteria. Otherwise what we need to return is, we need to return 0 here. Okay, so this is how we need to code it up. Let's try and quickly compile this code to check if it is working on the sample test cases or not. Okay, so it says that there's a spelling mistake. Okay, PROPERTY. Okay, let's try and compile it again. So it works fine on the sample test case. Let's try and submit it. Hopefully it should get accepted. So you can clearly see that our code was able to pass all the test cases. Now talking about the time complexity and the space complexity of my code. So for my code, since I'm iterating through all the nodes exactly once, right? So the time complexity would be order of n, because we are traversing all the nodes in the scenario. And then the space complexity would be what? Since I'm using recursive approach, so order of n space complexity will also be taken for the recursive stack space. And this problem previously has been asked in companies like Intuit, which is a very good product based company. Okay, so if you understood this problem clearly and the doubts are clear, make sure to mention that in the comments that you have understood, and you can give us a +1 in the chat and hit the like button as well. If you have any doubts regarding this problem or the approach that I have, so you can ask it in the comments and I will be very happy to answer them all. Thank you and take care, guys. Keep coding. Thank you.